The safest machine on a factory floor is supposed to be the one that repeats itself. An industrial robot performs the same motion through the same volume of space, thousands of times over, with no fatigue, no distraction, and no improvisation. That reliability is the entire safety argument for automation. Take the human out of the dangerous, repetitive job, and the danger goes with them. And yet, the name Robert Williams is remembered in industrial safety history for the opposite outcome. He is widely described as the first recorded fatality involving an industrial robot. So the question this episode has to answer is not why a machine malfunctioned. It is harder than that. Why does a machine that is behaving exactly as designed become lethal the moment a person steps into its working space? And a second question sits underneath it, one that matters for how honestly this story can be told. What does the documented record actually preserve about a case that gets cited constantly, and what has been filled in by repetition? I want to be clear about my evidence before I go further, because this is a story where the temptation to embellish is enormous. The source material available for this episode is narrow. It confirms that industrial robots are machines used in manufacturing, and that the United States Occupational Safety and Health Administration has investigated dozens of robot-related deaths and injuries, which are cataloged in its accident search records. It does not supply a scene, a sequence, a plant layout, or an official finding for this specific case. So I am not going to invent one. What I can do is explain the failure mode that makes this category of accident possible, and show why one name became the marker for it. An industrial robot does not see you. That is the whole problem, compressed into 5 words. A robot of this era executes stored positions. It moves an arm to a coordinate, closes a gripper, rotates, releases, and returns. And it does so with force and speed calibrated for metal parts, rather than for people. There is no perception of a human body in its path, no instinct to flinch, no concept of an obstruction that deserves mercy. The machine is not hostile, and it is not malfunctioning. It is indifferent, because indifference is what it was built to be. Everything that makes such a machine safe, therefore, lives outside the machine. Physical separation, barriers, and the discipline of never sharing space with a moving arm. Safety is not a property of the robot. It is a property of the boundary drawn around it. That boundary logic worked well enough that confidence in it grew quickly. Automation genuinely did remove workers from some of the worst jobs in manufacturing, the ones with heat, repetition, and crushing loads. When a robot took over a task, the injury statistics for that task tended to improve, and the machine's consistency became a selling point rather than a hazard. The reasoning was intuitive, and it was mostly correct. A device that never gets tired and never gets careless looks like the answer to human error. Here is the assumption buried inside that reasoning. Removing a person from routine operation does not remove them from the system. Somebody still has to load it, clear it, inspect it, adjust it, and retrieve what it drops. Automation does not delete human exposure so much as relocate and concentrate it, moving risk out of normal production and into those irregular moments when a person and a powered machine share a space that was never designed for 2 occupants. The routine gets safer. The exception gets far more dangerous, and the exception is exactly the situation that written procedures of the era addressed least. That is a general engineering principle, offered as interpretation rather than as a finding about this specific event. I'm stating it that way deliberately. I will not narrate what Robert Williams was doing, what the machine did, or what anyone said, because the evidence supplied for this episode does not support that reconstruction, and a fabricated sequence would be worse than an incomplete one. What survives, and what is genuinely load-bearing, is the category itself. A worker died in the presence of an industrial robot, and that death became the reference point for treating robots as a distinct occupational hazard rather than as one more machine on the floor. The Occupational Safety and Health Administration has investigated dozens of robot-related deaths and injuries. That single fact, from the record available here is the most important line in this story, and it works in two directions. It tells us the first case was not a freak event that safety engineering could dismiss as bad luck. It was the opening entry in a series long enough to justify its own investigative record, searchable and countable, decades on. And it tells us something less comfortable. The hazard did not end with recognition. Naming a failure mode, writing it into standards, and building barriers around it reduced the frequency of these deaths, but did not eliminate them, because the exception moments never fully disappear from a working factory. Investigation into accidents of this type has to separate layers that get collapsed in casual retellings. There is the proximate event, the physical contact between a person and a moving machine. There is the technical cause, which in this class of incident is usually not a broken robot, but an intact robot doing its programmed work in a space it was never supposed to share. Then there is the organizational cause, which lives in how work was planned. Whether entering the machine's envelope was treated as an extraordinary act, requiring the machine's power to be positively removed, or as a small practical step someone took to keep production moving. Those layers point at different fixes. Blame the machine and you get better robots. Blame the system and you get better boundaries. And the boundaries are what actually protect people. The ethical layer is the one that is easiest to skip. A safety regime that depends on a worker never being in the wrong place has quietly transferred responsibility to the person with the least authority over how the plant runs and the least power to slow it down. Designing a system so that a single ordinary human decision can be fatal is itself a design choice, made by people who are not the ones exposed to it. So what changed? At the supported level of certainty, the honest answer is this. The death of Robert Williams is the point where robot-related harm became a tracked, investigated category rather than an unclassified industrial accident. The durable consequence is not a single regulation I can cite from the material in front of me. It is the existence of an official accident record that a regulator maintains and that anyone can search, which is what makes the modern approach possible at all. Physical separation, controlled entry, and the rule that the space a robot can reach belongs to the robot whenever it has power. The uncomfortable part is that this understanding was purchased rather than predicted. The mechanism was not hidden. A machine that cannot perceive people moving with industrial force in a space people occasionally enter is a hazard visible from first principles. It took a person's death to convert that available reasoning into enforced practice, and the record of dozens of later investigations shows how slowly and imperfectly the conversion held. That is the pattern worth carrying out of this story. When a new technology removes an obvious danger, it rarely removes the danger from the system. It moves the danger to the places nobody has thought to look yet, and it usually takes someone getting hurt in one of those places before anyone maps it. This content is for educational purposes only. Do not attempt to recreate any described experiment or procedure.